By the standards of aeronautical thinking, the journal Samolyet wrote in September 1934, in boldness of resolving assigned problems and in the culture of the quality of aircraft being built, the designers of the Kharkiv Aviation Institute have every right to claim first place in the Soviet Union. Such flattering praise from an authoritative magazine confirmed the high hopes of the Soviet air leadership for the work of Isaac Hryhorovich Neman's design group in creating high-speed aircraft. The young engineers of the Kharkiv Aviation Institute strove to justify that trust. Beginning in January 1934, the design office of the research sector at the Kharkiv Aviation Institute, while simultaneously designing the HAI-6 and HAI-7 aircraft, and freed from work on the passenger aircraft, the team of lead designer Lev Dmitrovich Arsun began developing a two-seat armed multi-role reconnaissance aircraft and a light bomber. This aircraft was intended to compete with the machine designed by Kocheragin. The technical specification issued by the Air Forces Research Institute required development of the primary aircraft variant around a domestic engine of 480 horsepower, with the possibility of later replacement by the imported American Cyclone engine of 712 horsepower. With the first engine, the aircraft had to reach 211 miles per hour near the ground and have a climb ceiling up to 25,590 feet. Armed with two machine gun mounts, the aircraft was to carry from 440 to 100 pounds of bombs over a distance of 497,745 miles. When fitted with the American engine, speed at 6,560 feet would increase to 217 miles per hour, and maximum altitude would rise to 26,245 feet. Having the same layout as the passenger aircraft, the new reconnaissance plane retained a wooden structure with reinforced plywood skin and some design features of its predecessor, differing from it only in smaller dimensions. The wing, fuselage, and tail were designed with smooth plywood skin that acted as a load-bearing structure. The pilot's cockpit was made in the style of the American plane with a characteristic visor projecting forward. The engine carried an American-style cowling, which significantly reduced aerodynamic drag and improved cooling. The aircraft featured an elongated fuselage layout with a large longitudinal distribution of weight. To prevent a sharp rearward shift of the aircraft's center of gravity due to the placement of the navigator bombardier's cockpit in the rear fuselage, the new reconnaissance plane, as with the passenger aircraft, used a wing with highly swept removable outer panels. Similar aircraft types developed in advanced countries in the early 1930s typically used a movable defensive gun installation located in the crew cabin to protect the rear hemisphere, which narrowed the firing arc. At the same time, the gun installation created significant aerodynamic drag and worsened overall aerodynamics. A further step toward aerodynamic refinement on the new reconnaissance aircraft was a revision of the weapons arrangement typical of a fast combat airplane. An enclosed gun turret was located behind the pilot's cockpit, above the wing trailing edge, which improved fuselage lines and increased the rear hemisphere firing sector. On all reconnaissance aircraft of that period, bomb loads were carried on external racks. Here, Neman remained true to his motto, no protruding detail in the airflow. For this reason, for the first time on a reconnaissance aircraft, the bomb stowage was removed inside the fuselage and placed on cassette racks, which provided a significant aerodynamic improvement compared to similar class aircraft in service. Moreover, horizontal bomb stowage ensured greater bombing accuracy compared to vertical stowage. The aircraft embodied many bold ideas. Practically for the first time in domestic aviation, remote control of the bomb bay doors was implemented using a locking mechanism for the door controls together with control of bomb release. The machine was fitted with the photographic turret developed on the previous aircraft, with the camera hinge mounted on a frame. When designing the retractable landing gear, operational experience from the passenger aircraft's gear was taken into account. Balloon-type wheels were replaced with ordinary wheels, which made it easier to retract the gear into the reduced wing dimensions. Instead of a truss, a landing gear design was used with a single strut containing a shock absorber inside the strut and a brace. In order to reduce the pilot's effort when turning the retraction extension handle, the actuator mechanism was substantially redesigned. Retraction and extension of the gear were still carried out by a chain drive, but the actuator was powered by the aircraft's pneumatic system supplied from an onboard compressed air cylinder at a pressure of 290 pounds per square inch. To retract the gear, the pilot first opened the cylinder regulator, Then, by moving the gear handle counterclockwise for 33 turns, he raised the gear and locked the wheels into place. To extend the gear, the pilot acted in the reverse order. During the creation of an entire set of mechanisms on the new reconnaissance aircraft, many difficulties were encountered. There were objections from the military tied to the idea that the presence of mechanization supposedly reduced flight safety. The greatest doubts among skeptics were caused by the presence of retractable landing gear on a combat aircraft. In the debate, the decisive factor turned out to be the operational experience of a passenger aircraft, and later of a fighter. It was proven that even a landing with the landing gear not extended was quite safe and could be successfully carried out. Urgent work on the previous aircraft delayed the design of the new reconnaissance aircraft with a Soviet engine for a whole year. It seemed that the aircraft had hopelessly fallen behind its competitor with a French engine of 780 horsepower. But at the beginning of 1935, the designers of the Kharkiv Aviation Institute, freed from the design work on the fighter, fully set about catching up with their competitors. The Scientific and Technical Committee of the Air Force approved the project proposed by Neman. The commission reviewing the mock-up was successfully passed. However, the workshops of the Kharkiv Aviation Institute were engaged in the production of other aircraft, and the manufacturing of the prototype of the new reconnaissance plane with a Soviet engine was assigned to the workshops of a nearby plant. The construction of the new reconnaissance aircraft, known as the Fiver, at a serial factory progressed slowly. The plant was fully loaded with the production of another aircraft and with preparations for the release of a new cannon-armed fighter. Moreover, the technical requirements for the new aircraft were constantly changing. Much had to be reworked and refined before the machine was ready for flight. Designer Neman was particularly worried about the power plant of the new aircraft. The engine planned for installation had become hopelessly outdated, and the need for its replacement became obvious. Yet no suitable air-cooled aviation engines were available in serial production. Here, Neman encountered the most difficult obstacle that hindered the development of Soviet aviation in the 1930s. He, like many other aircraft designers, found himself trapped by a genuine famine of powerful and reliable serial engines for his aerodynamically advanced aircraft. It is known that in all 13 years, wrote leading aviation industry specialists in an appeal to Stalin on August 13, 1930, not a single completed domestic aviation engine has been created in the USSR that would stand on Soviet aircraft. In all this time, more than 40 aviation engines have been designed by various organizations in the Soviet Union, 30 of them handed over for production, about 15 built, but not one of them is mounted, nor is likely to be mounted, on aircraft. Soviet experimental construction is utterly barren. This letter, unprecedented in its frankness, gave impetus to rapid changes in aircraft engine building. By decision of the Revolutionary Military Council and the Supreme Council of the National Economy of the USSR, the Institute of Aviation Engines was established in Moscow for experimental construction. The building of 3 new aircraft engine plants began. In 1931, plants were laid down in Perm and Voronezh, designed for the production of air-cooled engines, and in 1932, a plant in Kazan for the production of liquid-cooled engines. For the urgent purchase of licenses for the production of new engines, 2 competent delegations were sent abroad. One of them, headed by the head of the Central Institute of Aviation Engines, Ivan Ivanovich Poberezhsky, studied the engines of the American company Curtiss Wright. The other, led by the chief designer of the Rybinsk plant, Vyacheslav Yakovlevich Klimov, purchased in France in 1932 6 new engines at once: 1 Hispano-Suiza, 3 Renault Bengali models, and 2 Gnome Rhone Mistral Major. In March 1935, the head of the aircraft department of the main directorate of the aviation industry, Alexander Alexandrovich Mashkevich, gave approval for the replacement of the engine for the new aircraft. The old motor was replaced with the newly purchased in France Gnome Rhone Mistral Major. The Kharkiv Aviation Institute was allocated one of the 3 engines purchased as samples. However, it was not possible to obtain it. The engines went to the Central Institute of Aviation Engines and to the plant where their production under a new designation was planned. While waiting for the new engine, the static tests of the fuselage of the new aircraft were delayed. On March 4, 1936, Igor Georgievich Neman received an urgent task from the deputy head of the main directorate of the aviation industry, Andrei Nikolaevich Tupolev, to revise the design of the aircraft for a less powerful but more reliable radial 9-cylinder air-cooled engine, the American Wright Cyclone, with a deadline for the aircraft to be ready for testing by May 1st. The production of these engines under license from the American company Wright was successfully mastered by the Stalin plant in Perm. Under the leadership of chief designer Arkady Dmitrievich Shvetsov, and with the technical assistance of American specialists, the engine was adapted to Soviet conditions of production and operation. With an initial service life of 100 hours, the engine's power was increased to 635 horsepower by enlarging the cylinder diameter and introducing a supercharger. Starting in the autumn of 1935, these engines were supplied to aircraft manufacturers. The engine became one of the mainstays of Soviet aviation. The decision to use this engine on the new aircraft was forced, but it allowed the proven propeller engine group from another airplane to be applied and the machine to be put into the air in the shortest possible time. Assembly of the prototype was carried out in the workshops of the Central Experimental Workshop of the Kharkiv Aviation Institute, because the plant's assembly shop had been entirely given over to modifications of the fighter with a cannon. May 1936 proved capricious. The weather cleared only at the end of the month, and on a cool morning, the assembled airplane was moved to the flight field of the factory airfield, where final adjustments of all systems and mechanisms took place. On June 7th, the test pilot Boris Mykolaievich Kudrin began taxiing runs and short flights. During this work, the tailwheel broke, and Neman decided to release the aircraft for tests with a simple temporary tail brace. On subsequent taxiing runs, it became clear that under the aircraft's load, the tire treads of the landing gear wheels ran too close to the shock-absorbing struts, which required urgent modification. Only after he was satisfied that all the defects he had noticed in the operation of the aircraft's units had been fixed did Kudrin raise the machine into the air at the end of June 1936. The new aircraft lifted off the ground easily and showed good controllability and sound flying qualities in flight. Factory flight tests were conducted over 20 flying days. 42 flights were performed, with changes being made almost every day to eliminate encountered defects. They changed wheel tires, eliminated air leaks in the pneumatic system, and installed a new carburetor. But despite its shortcomings, it was clear that Neman had managed to create the most advanced reconnaissance airplane of its time. Its maximum speed exceeded that of the aircraft in service by 68 miles per hour. Soon, the HAI-5 was transported to Moscow, to the Shelkovsky Airfield of the Air Force's Research Institute, where its state trials took place from August 29 to October 24, 1936. The military test team, led by military engineer 3rd Rank Mykola Serhiyovich Kulikov, included Chief Pilot Senior Lieutenant Anatoly Kuzmich Dolgov, Navigator Arkady Mikhailovich Brindinsky, and Test Pilot Captain Petro Mikhailovich Stefanovsky. The HAI-5 prototype was fitted with a brand new American Wright Cyclone engine and a Hamilton fixed-pitch propeller. Reliable engine operation allowed the Institute's team to carry out the full cycle of flight tests, which comprised 117 recorded flights. The obtained performance figures fully satisfied the military. With full combat load and a takeoff weight of 55 out of 40 pounds, the aircraft reached a speed of 241 miles per hour at an altitude of 8,200 feet and a maximum range of 900 miles. According to the testers' evaluation, the HAI-5 had satisfactory stability about all three axes. Its piloting technique did not differ from that of other reconnaissance-type aircraft, and all flight maneuvers, including loops, aileron rolls, and spins, were performed fairly easily and without strain. The airplane responded well to the controls, and with use of the trim on the elevator, the load on the control wheel was slight. Performing a landing required a smooth recovery from gliding and increased attention by the pilot during leveling. Testers noted that compared with the R-5 and R-3 reconnaissance planes in service, the HAI-5, even with a fixed-pitch propeller, had significant advantages in the horizontal plane, was not inferior to them in climb rate, provided better visibility for crew members, and had larger firing arcs. During night flights, the aircraft also performed well, being more convenient and easier to fly than the R-5. However, the prototype HAI-5 hardly resembled a full combat aircraft. Its special equipment and armament left much to be desired. The radio set did not provide full radio communication with ground subscribers. The arrangement of fixed defensive armament provided only a single fixed HKS machine gun installation with 500 rounds in the right wing of the machine. A second HKS machine gun with a similar ammunition load was used as a movable gun for defense of the rear hemisphere. For it, the designers adapted a hatch turret installation with a spring compensator covered by a transparent hood. In the fuselage bomb bay, there was a cassette bomb rack with 8 beam holders of 110 pounds each. Only the photographic turret with its camera earned the testers full respect and subsequently remained unchanged on all aircraft modifications. At the same time, the Institute was completing tests of the high-speed reconnaissance R-9 designed by Semen Oleksiyevich Kocherygin. A comparative evaluation of the two prototypes was carried out by a group of test pilots. Although the HAI-5 lagged behind the R-9 with fixed landing gear by almost 37 miles per hour in maximum speed, and there were serious complaints about its armament, the Air Force's leadership nevertheless favored the Kharkiv design as one that met the main task requirements and was more progressive. It was noted that the HAI-5 had a margin of strength for modernization to accept more powerful M62 and M63 engines. In the conclusion signed by the Chief of the Air Forces Yakov Ivanovich Alksnis on November 2, 1936, it was stated that, in view of the obvious superiority of the HAI-5 compared to the reconnaissance aircraft in service with the Workers' and Peasants' Red Army, to petition the People's Commissariat of Defense Industry for its introduction into serial production under the designation R-10. The decision reflected the Air Force's leadership's entirely natural desire to replace the obsolete reconnaissance aircraft and attack aircraft R-5 and R-3 as soon as possible with a more modern airplane, even if it did not fully meet the newest requirements. As a result, in the Soviet Air Forces, the R-10 was initially assigned a short service life. It was to fill the gap in the combat aviation structure and serve as a transitional machine toward more modern battlefield aircraft. It was believed that the experience gained from mastering parts of the R-10 aircraft would later allow for trouble-free operation of more advanced machines built under the conditions of the Ivanov competition. There was still a faint hope for Kocherygin's R-9, with which experiments continued. Although the main directorate's order of August 7, 1937 authorized military trials of 3 R-9 aircraft produced by Factory No. 1, those trials only confirmed the results obtained earlier. Impressed by the first successes of KI-5 and without waiting for the Air Force's final decision, the leadership of the first main directorate of the People's Commissariat of Defense Industry on September 23, 1936, ordered the launch into production at Factory No. 135, taking into account the discovered defects of the 3 prototype R-10 aircraft and 10 machines of the first series. The deadline for delivering the main machines intended for military trials to the airfield was set for March-April 1937. Manufacture of the serial specimens began simultaneously with substantial redesign work. During this period, the team of the Special Design Bureau of Factory 135 endured great difficulties. Under extremely tight deadlines with no concessions for the complexity of the forthcoming work, and despite an acute shortage of people and time, tens of thousands of working drawings for the R-10 were prepared, reflecting every change introduced into the experimental prototype's design. Great hopes were pinned on Arkady Dmitrievich Shvetsov's work to modernize the M25 engine. Engine builders from the Urals were successfully developing 2 directions for improving the performance of the M25 and M63 engines, on which Neman based the future application of his aircraft. Neman understood that a powerful engine alone would not guarantee a long life for the aircraft. The aircraft itself had to be improved so that it would surpass competitors. Most of the military's complaints concerned poorly chosen armament, which they completely rejected. Neman found himself in a very difficult position. In addition, the factory began to fulfill the production plan for the first series aircraft for testing in the armed forces. They had to take a known risk in advance, release drawings to serial production, knowing that some of them would be changed during subsequent refinements. He began by creating within the Design Bureau a special group of engineers, graduates of the Kharkiv Aviation Institute, to design the aircraft's armament. This proved to be a complicated task. There were no armament specialists on hand. Neman put the young engineer Vladimir Mikhailovich Likode in charge of the group. Taking copies of the spaces allocated for armament, Likode went to Moscow. There, at Factory No. 39 in Sergei Vladimirovich Ilyushin's brigade, He was to undergo an internship with the deputy chief designer for armament, Yakov Ivanovich Maltsev. Ilyushin's employees treated the Kharkiv team's problems with great attention and helped select the full set of special equipment for the R-10. An introduction took place with the chief designer of bomb carriers and bomb beam racks at the Nozenko factory. Some of his developments that were already in serial production were suitable for the constructed machine. With Maltsev's help, it became possible to meet the designers of turret machine gun mounts, Ivan Vladimirovich Venevidov and Georgy Mikhailovich Mozharovsky, who were completing the fabrication of a new armored turret in the workshops of the Air Force Academy. At the military's request, a second fixed mount for a wing machine gun was installed on the serial aircraft. 2 cassette-type bomb carriers were placed on special vertical beams attached to reinforced frames. The entire installation was operated from an automatic electric bomb release mechanism. The bomb armament, in various combinations, amounted to 440 pounds, and in an overloaded variant to 880 pounds. For accurate bombing, an optical sight was installed in the gunner's cockpit. And yet the main innovation in the armament of serial R-10s was a rotating turret for firing into the rear hemisphere, which provided, alongside good aerodynamics, easy rotation at high speeds to increase the weapon's maneuverability in air combat against faster enemy fighters than before. The turret installation was equipped with aerodynamic compensators. They balanced the action of the airflow on the gun barrel and significantly reduced the effort required to rotate the turret in the horizontal plane. Reduction of the effort required to move the weapon vertically was achieved by placing the wing-shaped supports for the gun mount near its center of mass. The large size of the turret's hood improved visibility and the gunner's working conditions. The hood, when tilted back to a certain angle, automatically detached from the aircraft, allowing the gunner to quickly abandon the machine if necessary. Tests of the R-10 revealed insufficient control surface area in the rudders and tail unit. To ensure recovery from a spin, the designers increased the vertical tail by 29% and the horizontal tail by 23% on the serial machines. The original crew canopy with a visor was replaced by standard glazing. The tail skid gave way to a tail wheel. The structural changes made it possible to increase the reliability of the remote control mechanism of the photographic turret for future reconnaissance photography. As drawings were completed, they were immediately sent to the shop. In October 1936, the main directorate's leadership once again changed the aircraft production deadlines. An order arrived at the factory on accelerating the production of the main series of the R-10 aircraft. The time allotted to build the first 2 serial machines was shortened to 2.5 months, and the third machine was ordered to be built as an attack aircraft with an engine by June 1, 1937. Someone was eager to report the start of production of the new high-speed reconnaissance aircraft as soon as possible. Everyone understood that the new deadlines were unrealistic, but the factory and the design bureau mobilized all their forces to fulfill the task with minimal delay. There was a shortage of experienced production specialists, deliveries of materials and semi-finished products were often delayed, and, moreover, the painful process of continuous changes continued. In January 1937, the production of wooden fuselages, wings, and tail units for the main series was assigned to the central support workshops of the Kharkiv Aviation Institute, where craftsmen and workers with experience in wooden aircraft construction were available. A month later, these workshops were incorporated into the design bureau. To organize woodworking shops, a group of specialists from the All-Union Institute of Aviation Materials arrived at the plant in February. At the head of the final assembly shop, Neman placed the experienced engineer and specialist in wooden structures, Anatoly Andreevich Lazarev. The ongoing reconstruction inevitably affected the deadlines for aircraft delivery by the plant. The last sheet of the R-10 serial drawing set was transferred to production only at the beginning of March. On March 20th, Mikhail Mikhailovich Kaganovich, head of the first main directorate of the People's Commissariat of the Defense Industry, arrived at the plant with inspection. He once again confirmed the special attention given to the production of the R-10, reviewed the state of affairs, and set a new date for the release of the first serial aircraft by May 20th. At the same time, Kaganovich announced that the plant's production plan for the R-10 in 1937 amounted to 200 machines. Considering that the aircraft as such did not yet exist, only the prototype had flown, it was clear that the figure was inflated and needed by the main directorate only for victorious reports. After the visit of the industry leader, the shops urgently laid down the second and third R-10 series of 10 and 20 aircraft, respectively. The plant management decided at any cost to produce the first aircraft by May 1st to mark this important achievement on the Day of International Workers' Solidarity. For 20 days, engineers and workers practically did not leave the plant, assembling the first serial R-10. However, not all production managers supported such hasty work, which resulted in a huge number of defects and shortcomings. Disagreeing with these working methods, Chief Engineer Nikolai Dmitrievich Vostrov left the plant. Early in the morning on May 1, 1937, the freshly painted aircraft was rolled out from the assembly shop to the airfield. Several more days were spent on engine and propeller adjustments. The engine used the same propeller manufactured by the Hamilton Company. Deliveries of new armament sets were delayed, so the first serial machines were fitted with old turrets. On May 4th, around 7 in the evening, the plant's test pilot, Pyotr Ivanovich Kotov, successfully carried out the first flight of the serial R-10, which lasted 15 minutes. The tests progressed successfully, and during the fourth flight on May 20th, Kotov tested the retraction and extension of the landing gear in the air. At the beginning of June, 2 more machines were released, with military test pilot Captain Ivan Petrovich Burilin also joining the flight program. In June 1937, one R-10 arrived at the Shchelkovo airfield at the Air Force Research Institute, where Nikolai Sergeyevich Kulikov's team conducted additional state tests to determine the aircraft's spin characteristics with modified tail surfaces. Specifically for these tests, designer Neman installed an anti-spin water tank behind the navigator's seat. The water tank, which could be emptied during flight if difficulties arose in exiting a spin, allowed the aircraft's center of gravity to be shifted by 7–8%. Test pilot Anatoly Konstantinovich Dolgov confirmed that the aircraft easily recovered from spins, meeting all flight safety standards. However, numerous structural defects, including constant failures of the tailwheel attachment unit, which plagued everyone, indicated a low production culture. To improve the quality of the serial machines, in June 1937, the plant created a Serial Design and Technology Bureau from engineers, headed by engineer Anatoly Ivanovich Unik with his deputy Ivan Dmitrievich Kravchenko. The bureau was assigned all work related to support and refinement of the aircraft in production, while the main group of designers continued further modernization of the aircraft. Finally, even in Moscow, they understood the complexity of launching the aircraft into series production. At the end of June, the plant's aircraft delivery program was changed. For 1937, only 70 machines were scheduled for release, but with a plan for 300 units in 1938. Moreover, they intended to arrange cooperation with the Kharkiv Aviation plant for the production of wooden assemblies, and the plant director was instructed to deliver 3 sets of new armament to the factory no later than the end of December. The issue of launching the aircraft became a key matter in the work of the Soviet aviation industry. The Defense Committee took up the resolution of the problem. On behalf of Vyacheslav Mikhailovich Molotov, information for the committee about the state of production was prepared by the head of the Air Force, Yakov Ivanovich Alksnis. The meeting of the Defense Committee, at which the fate of the aircraft was decided, took place on July 20th. I personally made 3 flights in the aircraft designed by engineer Neman, Alksnis said in his speech. The airplane is exceptionally light and easy to handle, quite accessible to pilots of average and even low qualification. The flight tactical performance of the airplane is comparatively high, maximum level speed at an altitude of 19,685 feet, 264 miles per hour with the engine. This speed was actually achieved during tests, and pilots and engineers do not consider it to be the limit. The airplane is stable on landing and has no tendency to swing either during the takeoff run or during the roll after landing. The machine passed a spin test and exits a spin simply and well, without difficulties. Unfortunately, despite all the comparatively high flight qualities, ease of control, and stability in flight, the airplane has some relatively minor structural and production defects that can be relatively easily corrected in serial production. Weak effectiveness of the braking wheels, insufficient strength of the tail wheel, and others. In its combat properties and flight tactical data, the airplane deserves to be produced in large quantities for the armament of the Soviet troops, and reconnaissance aviation and its production should be vigorously accelerated. The airplane is of wooden construction, so its production is possible not only at aviation plants but also at agricultural machinery plants. I consider it necessary to propose presenting my considerations on accelerating the production of the airplane and expanding the production base by implementing it at 1 or 2 agricultural machinery plants in parallel with production at the main plant. To instruct the chief designer of the airplane, Comrade Neman, to modify the airplane to increase the maximum speed to 298 miles per hour. To award orders of the Soviet Union to both Neman and his closest assistants who created the airplane. Unfortunately, Yakov Ivanovich Alksnis's last proposal was not supported, and Yakov Ivanovich himself was soon repressed and executed as an enemy of the people. On July 23rd, a government decree was issued on the deployment of serial production of the airplane at the agricultural machinery plant Sarkombane in the city of Saratov. In August, a representative commission flew to the city on the Volga, headed by Yakov Ivanovich Alksnis, Boris Lvovich Vanikov, and Andrei Nikolaevich Tupolev, where the transfer of Sarkombane into the aviation industry took place. The preparation of aircraft production at the plant and the airplane launch were placed entirely in the hands of the people from Kharkiv. Neman had to send 20 of his best designers and production specialists to Saratov. The plant's engineering staff was formed mainly from specialists sent from the aviation factories of Moscow, Kazan, and Taganrog. Immediately, 10 aircraft of the first series were put into assembly from units and parts manufactured in Kharkiv. Several months of intense work at the plant went into finishing 3 main aircraft with engines equipped with fixed-pitch propellers with widened blades. In September 1937, the machines were handed over for military tests to the 20th Separate Reconnaissance Aviation Squadron of the 43rd Aviation Brigade of the Kharkiv Military District. New armament sets still were not available, and the testing task was reduced to studying the behavior of the airplane as it was adopted by line pilots. To organize the training of flight and technical personnel, the plant sent engineers Anatoly Ivanovich Unik and Grigory Andreevich Novak to the brigade. The military testing of the airplane in the 43rd Brigade was led by Captain Stukalov. Soon, 2 more first-series airplanes were added to the flights, and testing continued until December 1937. Military pilots noted that the airplane had high speed, ease of control, and stability in flight. The machine was maneuverable and readily performed all figures of advanced aerobatics. Among the shortcomings, it was noted that the engine overheated badly in hot weather, which forced flights on the airplane to be made early in the morning or in the evening. Air Force pilots discovered more than 100 different production defects on the airplanes, including those that threatened flight safety and reduced flight performance. To correct the pilots' and technicians' remarks, the engineer-designer Georgy Andreevich Novyak was appointed chief designer of the serial production of the R-10 at the plant. To more quickly implement changes in the design of the serial machines, in November 1937, by order from Moscow, the Plant Design Bureau was subordinated to Neman. At the end of 1937, the plant received the first turrets and new bombing equipment. After refinement, the main R-10 airplane with the new armament underwent tests at the Noginsk Proving Ground in February 1938. The designers successfully coped with the difficult task of improving the combat capabilities of the airplane. The R-10 armament withstood tests without serious changes and thereafter caused no complaints. However, the first 26 serial R-10s with M25A engines, built by the plant in 1937, still had the old turret. At the request of the Air Forces, starting from the R-10, an additional fuel tank in the fuselage behind the pilot's seat with a capacity of 43 gallons was installed. From the 4th aircraft, R-10s were fitted with ailerons and a rudder with a framework of duralumin tubes covered with fabric. From the 10th aircraft, a new 2-blade metal propeller with variable pitch in flight was used. With it, they achieved a high maximum speed while also obtaining good takeoff and landing characteristics. From the 34th aircraft, the tail unit, instead of being made entirely of wood, was manufactured from duralumin tubes, and from the 35th, the welded fuel tanks were replaced with riveted ones. From the 41st aircraft, a new exhaust collector was installed. On December 24, 1932, during another acceptance flight at the plant, a catastrophe occurred. The test pilot and the head of the plant's flight test department were killed. The opinions of the accident commission members on the causes of the tragedy were divided. Some believe the tragedy was due to the unreliability of the reloading system for the wing-mounted machine guns and the complexity of this operation, while others blamed it on a piloting error. The investigation into the causes of the incident and the shortcomings of the R-10 aircraft was taken over by specialists from the NKVD. By that time, through the hands of the People's Commissar for Internal Affairs of the USSR, Yezhov, and his subordinates, the best aircraft design bureaus in the country had literally been crushed. Apparently, it was now the turn of Neman's design bureau, where they zealously began searching for espionage and treason against the motherland. On February 11, 1938, the head of the 5th Department of the Main Directorate of State Security of the NKVD of the USSR, Nikolaev, sent an extensive special report to Yezhov about the investigation of sabotage at the plant. Nikolaev's conclusion was categorical. The untimely failure to eliminate the defects in the R-10 aircraft discovered during testing and the failure to ensure the production of these aircraft fully fall within the forms of sabotage that were widely practiced by saboteurs in the Air Force and the aviation industry, and requires intervention from the leadership. Along the GUGB line, instructions are being issued to investigate through intelligence and investigative measures the reasons for these delays and their initiators. While the Kharkiv agents were searching for saboteurs, Neman and the plant director, Vasilyev, were summoned to Moscow to Mikhail Moiseyevich Kaganovich for organizational conclusions. At that time, they managed to prove the objective reasons for the identified shortcomings. In Neman's explanatory note, it was stated, "The defects listed in the documents did occur on the first R-10 aircraft. During military tests, all of them were clarified and are being eliminated. All measures have been taken, and therefore there is no reason to consider that there is a threat of disrupting the 1938 program. The plant is experiencing major growing pains but is now improving. But the first blows from the NKVD against the plant did not take long to come." In April 1938, Neman's closest assistants, Semyon Yakovich Jolkovsky and Raphael Samuilovich Maron, were arrested right at their workplaces, followed shortly after by Yevgeny Ivanovich Bara and Arkady Isakovich Unik. The plant's management and the design bureau understood that a real threat of arrest hung over them. People closed themselves off, and an atmosphere of fear reigned in the teams. For comparison of the characteristics of the prototype aircraft with its serial sample from June 21 to July 22, 1938, at the Air Force Research Institute airfield, lead pilot Anatoly Konstantinovich Dolgov conducted flight tests of the R-10 aircraft with the M25V engine. It was noted that changes in the first production series of the aircraft led to an increase in its flight weight by 360 pounds. The flight performance worsened, with the maximum speed of the aircraft reduced to 224 miles per hour at an altitude of 9,500 feet, and as a result, its useful load decreased. However, the deterioration of flight performance was not the main shortcoming of the production aircraft. Once again, a huge list of design and manufacturing defects emerged. It revealed 8 defects dangerous for flights, 6 that reduced the safety of the aircraft, and 84 that complicated its operation. As a result, in August 1938, the acceptance of R-10 aircraft by the military was suspended until the identified shortcomings were eliminated. The problems with the R-10 became the subject of discussion at a meeting of the Defense Committee of the Council of People's Commissars of the USSR. The fate of the R-10 aircraft was entrusted to a government commission headed by Sergei Vladimirovich Ilyushin. Arriving in Kharkiv, the commission members studied all the design documentation and the main technological processes of production. As a result, by protocols dated September 30th and November 30th, another 100 production defects of the R-10 were identified. The team of strength engineers consisting of Sergei Nikolaevich Shishkin, Anatoly Yuryevich Romashevsky, and Vladimir Mikhailovich Strigunov recalled design engineer Olga Konstantinovna Alpatova for about a month, every day for 8 to 10 hours, checked the Soviet calculations. They searched for counter-revolutionaries by order, but did not find any. For a month, Soviet workers lived under wild tension, and only diligence in work, in fact, saved them. Sometimes it seemed to her that it was her turn to go to prison. Had there been some mistake or oversight, the fate of several people would have been terrible. The plant director Vasilyev and chief engineer Nikolai Yevgenyevich Shvarev were accused of all sins. In their place, from Moscow came Solomon Zakharovich Neishtad as director and Brodyansky as chief engineer. competent production men from another plant. It must be said that Neman and his assistants clearly understood the causes of the aircraft's shortcomings and, with their characteristic persistence, worked on eliminating them. Moreover, by government decision from January 1939, the further development of the R-10 aircraft under a new index in which Neman took into account many of the identified shortcomings was to be launched into serial production. But Iosif Grigorievich Neman was not destined to complete this work. On December 11, 1938, he was arrested and sentenced to 15 years in camps for organizing sabotage at the plant and as an agent of foreign intelligence. Neman was accused that the R-10 machine was structurally unfinished and raw, yet was allowed into production. Despite the fact that in all the test reports these defects were noted, they were not eliminated, and no orders to eliminate the defects were issued by the former leadership and the former chief designer. As a result, all the machines produced by the plant up to August turned out to be unfit. In May 1939, the imprisoned Iosif Grigorievich Neman was sent to the aviation Sharaga to Andrei Nikolaevich Tupolev, where he worked on the Tu-2 aircraft. On July 19, 1941, by decree of the Presidium of the Supreme Soviet of the USSR, he was released with his conviction expunged. The Design Bureau, left without its leader, continued stubbornly, and probably out of fear, to work on improving the production aircraft. At the end of 1938, the Design Bureau was headed by the chief designer Alexei Alexeyevich Dubrovin, who arrived from Moscow and was assigned full responsibility for finalizing the R-10 and its modifications. The plant's design department was led by one of Neman's students, Ivan Dmitrievich Kravchenko. According to the plan, the factory was to produce 200 R-10 aircraft in 1938. The production capacities of the Kharkiv Serp-i-Molot plant were involved in manufacturing wooden components of the aircraft. Due to the suspension of military acceptance, only 100 aircraft were built in 1938. The work on eliminating defects was completed in April 1939, after which production was resumed. The results of the next rush job were summed up by the state tests of the aircraft, conducted at the plant airfield by a team from the Air Force Research Institute. This aircraft was a series-produced example on which practically all defects identified by the government commission had been corrected, and new fuel tanks protected against gunfire as well as an armored pilot seat were installed. Naturally, the empty weight of the aircraft increased again by nearly 66 pounds. However, thanks to improved production quality and certain design solutions, the maximum speed and rate of climb of the machine increased. The R-10, refined to the maximum in production, demonstrated the best flight performance of all tested machines. Its speed near the ground reached 213 miles per hour, and at an altitude of 16,400 feet, 235 miles per hour. However, based on the test results, the conclusion was made that the aircraft's performance with this engine did not meet the requirements of 1939, and in the future it could only be used for combat training. The R-10 continued to be produced at the factory until the end of September 1939. In total, 230 machines were completed that year. Of these, 205 were delivered to the Air Force and 21 to Naval Aviation. At the end of April 1939, all design work on the R-10 was discontinued. Pavel Osipovich Sukhoi was appointed as the new chief designer of the factory, overseeing the launch of a new short-range bomber into production. The Saratov aircraft plant also produced R-10 aircraft. Launching production was difficult, occurring simultaneously with the establishment of the entire aviation industry and the training of specialists for assembly and installation work. The first series of 10 aircraft, assembled from components delivered from Kharkiv, was built in early 1938. By the time production of this type ended in early 1940, the plant had produced 135 series machines. In total, the Kharkiv and Saratov aircraft factories built 493 series R-10 aircraft with various engines. The operational history of the R-10 in Air Force combat units began with the 43rd Aviation Brigade of the Kharkiv Military District, commanded by hero of the Soviet Union Nikolai Petrovich Kamenin. At the end of 1937, the first pilots to master the new reconnaissance aircraft were from the 20th Separate Reconnaissance Aviation Squadron, who had previously flown R-5 aircraft at the Sokolniki airfield. Training on the R-10 took place directly at the plant, in the workshops where series production of the aircraft was just beginning. In 1938, another squadron of the brigade, the 24th Separate Reconnaissance Aviation Squadron, was re-equipped with R-10s. It was decided to present the new aircraft at the May Day parade in Moscow. For this, in April 1938, the 20th Separate Reconnaissance Aviation Squadron, in full strength with 18 R-10 aircraft, flew to Moscow's central airfield. The parade was to be opened on an R-10 by Yakov Vladimirovich Smushkevich, Deputy Chief of the Air Force of the Workers' and Peasants' Red Army. From the factory, he was given a brand new silver-painted aircraft with a red inscription on its fuselage. To the commander of the May Day Air Parade, hero of the Soviet Union, Corps Commander Yakov Vladimirovich Smushkevich. But literally, a day before the parade, the unforeseen occurred. Technician Grigory Ivanovich Chaperny recalled, "When I was standing on the wing of my aircraft, a silver R-10 from the aircraft plant flew over us. Then the pilot pulled into a steep climb, turned, and went for another pass. On the second climb, the aircraft's engine seized, and it fell beyond the airfield into a small grove. Yakov Vladimirovich Smushkevich was supposed to lead the air parade in this machine. Here is what happened. When Smushkevich was getting into his reconnaissance aircraft, his mechanic went over to another machine. Suddenly, the mechanic heard the engine of his aircraft start. He rushed back and, seeing a pilot in the cockpit, quickly climbed into the navigator's seat without a parachute and took off with Smushkevich. When the aircraft was falling, the mechanic managed to jump out at an altitude of about 100 feet, landed in the branches of trees, and survived with only minor bruises. Smushkevich, however, received severe injuries. As it was later established, the cause of the crash was an ordinary oil system valve, which should not have allowed the engine to start unless it was opened. Due to the imperfection of the valve's design, Smushkevich was able to start the engine without the mechanic. Meanwhile, the mechanic assumed that if the engine was running, then the valve must have been open, and so the Soviet squadron was not allowed to participate in the parade. In 1938, based on the experience of combat in Spain and China, it was decided to transition aviation to a regimental system. In August, 3 aviation regiments were formed on the basis of the Aviation Brigade. Squadrons operating reconnaissance aircraft were assigned to a regiment under the command of Major Pyotr Ivanovich Mironenko. The reconnaissance squadron, commanded by Major Mikhail Ivanovich Gorlachenko, received the number 1, while the squadron commanded by Major Skripnik became number 2. As of January 1, 1939, the regiment had 25 reconnaissance aircraft. Among the first to master the new aircraft were 2 women pilots, Captain Maria Georgievna Mikhailova and Senior Lieutenant Elena Ivanovna Zelenko. Before flying the new reconnaissance aircraft, it was necessary to complete a certain training program on a 2-seat trainer aircraft. Once they mastered piloting techniques on it, the pilots transitioned to the new reconnaissance plane without difficulty. Soviet pilots remembered the reconnaissance aircraft as a light, well-controlled airplane that could perform all aerobatic maneuvers. Such elements as takeoff and landing were simple and accessible on it. The safety margin exceeded 8-fold overload and allowed rapid maneuvering both horizontally and vertically. The aircraft held steadily in steep turns, permitted combat turns with large bank angles and steep climbs, and remained stable on loops, Immelmann turns, and other figures. To put the aircraft into a spin, it was necessary to reduce the speed to 43 miles per hour, and at this point it would begin to spin with a slight rocking. It was enough to release the control stick for the airplane to easily assume a stable position and exit the spin freely. During landings with crosswinds, failures of the tailwheel mounting assembly occurred. As soon as the pilot pressed the brake, the balloon tire came out of its socket and the aircraft crashed. In reconnaissance flights, several cases were noted when the anti-flutter weight on the aileron detached, jamming the controls, and pilots had difficulty bringing the airplane back to the airfield. At the end of 1940, reconnaissance aircraft in the regiment were gradually being replaced by more advanced short-range bombers. In the flight logbook of Flight Section Commander Senior Lieutenant Sergei Mikhailovich Popov, it was recorded that he flew the reconnaissance aircraft from 1939 to 1941, carried out more than 600 flights, and accumulated 358 hours without a single failure. The second region where reconnaissance aircraft were employed was the Far East, where a military conflict with Japan was looming. On January 3, 1938, the plant shipped 15 aircraft under a special government assignment. On January 24th, another 2 reconnaissance aircraft were sent there. In the airplanes delivered to the Far East, all major defects were eliminated, and the armament set included a new machine gun turret. In February 1939, the fleet of reconnaissance aircraft in the separate Red Banner Army numbered 45 machines. During the battles at Khalkhin Gol in the summer of 1939, they were part of the Army group under Brigade Commander Alexander Ivanovich Gusev. The airplanes were delivered to the combat area by rail. The reconnaissance aircraft were received in the desert region of Tamtsak-Bulak by factory assembly teams specially sent from Kharkov. They were tasked with preparing the aircraft for combat in the shortest possible time. Unbearable heat and lack of water at the airfields created great difficulties, but despite this, by May 28, the machines were ready for flights. The dedicated work of the plant's workers and technicians was noted with gratitude by the command of the Red Army. On September 17, 1939, according to the Ribbentrop-Molotov Pact, on Stalin's orders, Red Army units began entering Polish territory. Aviation in this liberation campaign was commanded by Corps Commander Yakov Vladimirovich Smushkevich. Before the beginning of the Polish campaign in August 1939, recalled head of the plant's inspection department Ivan Dmitrievich Kravchenko. The chief military representative of the plant, Alexeyev, and I were summoned to Leningrad, to the aviation headquarters of the district. From there, Soviet representatives urgently flew to Pskov, where large aviation units were stationed. It turned out that about 150 reconnaissance aircraft had accumulated at the airfields, all of them showing widespread defects. Cracks had appeared in the covering at the junction between the fuselage and the fin. On many aircraft, there were failures in the operation of landing gear brakes. The cracks were dealt with very simply by Soviet specialists. The cracks were only in the bend of the top veneer layer and had not affected the remaining 8 layers. They were quickly filled and painted over. But for replacing the landing gear brake system, hardened springs were required. Such parts were manufactured only at the plant. However, since in a few days the reconnaissance aircraft had to take part in combat, the production of springs was organized by Soviet specialists in regimental workshops, where aircraft mechanics wound springs on ordinary lathes. In the Polish campaign, the use of reconnaissance aircraft was limited. They mainly carried out patrols, reconnaissance, and communications according to the missions of the ground troops advancing rapidly to the west. In 1939-1940, several regiments of reconnaissance aircraft were involved in combat operations in the Winter War with Finland. Here, Soviet pilots had to act in extremely difficult conditions. In 3.5 months, there were only 24 days of flying weather. Reconnaissance and attack missions against the Mannerheim Line had to be carried out under low cloud cover, in frost down to -58 degrees Fahrenheit, in snowstorms, and in Arctic winds. After the war with Finland, the lag in the technical equipment of Soviet aviation became so obvious that in the report on the combat actions of the Air Force on the Karelian Isthmus it was noted. The experience of the war once again showed that flight speed is the most important quality necessary for all aircraft types without exception. From this, the Soviet Union must conclude the urgent need to develop high-speed aviation technology. This same shortcoming was noted by the Central Committee Commission in May 1940 in connection with the transfer of the affairs of the People's Commissariat of Defense from Kliment Efremovich Voroshilov to Semyon Konstantinovich Timoshenko. In the Commission's report, it was stated, "The material part of the Red Army Air Force in its development lags in speed, engine power, armament, and durability behind the aviation of the leading armies of other countries." Among the aircraft subject to urgent replacement were the R-10s. However, quite unexpectedly, a new use was found for Igor Grigorievich Neman's airplanes. The expansion of the Air Force was accompanied by a sharp increase in the number of aviation training institutions. Their number was brought to 62 in 1940, and by mid-1941 to 111. The outdated R-10s began to be massively transferred to newly established aviation schools and flight colleges, where they were used for training and transition to the more modern Su-2 and Yak-4. In the pre-war years, R-10 aircraft were used to train pilots and navigators at aviation schools in Vasilkiv, Melitopol, Voroshilovgrad, Odessa, Poltava, and at the Chuhuiv Military Aviation School of Pilots. They were employed in the Kirovohrad Reserve Aviation Regiment for retraining personnel of combat units on new equipment. A certain number of R-10 aircraft were assigned to the aviation of the NKVD border troops along the borders with Germany and Romania. Pilots, navigators, and technicians for them were trained by the Aviation Department of the 2nd United Border School of the NKVD in Kharkiv. By June 22, 1941, there were up to 180 combat-ready R-10 aircraft and active aviation units stationed within the border and internal military districts of the European part of the USSR. They were part of the air forces of Combined Arms Armies and Corps Aviation Squadrons of Army Aviation. Many of them, still undergoing retraining, were without crews and were destroyed in the first days of the war on the airfields of the Western and Kiev Special Military Districts. Units that remained equipped with R-10 aircraft in the internal military districts were transferred in the summer of 1941 to the most dangerous sectors of the front. Thus, the 25th Army Aviation Squadron was based in Donbass at the airfield of the city of Kostiantynivka before the start of the war. The squadron was a well-coordinated aviation unit, and its pilots and navigators had a high level of general and flight culture. From late June to mid-July 1941, the 25th Army Aviation Squadron participated in battles on the Western Front. Due to heavy equipment losses, it was soon withdrawn to the rear. On July 20th, the squadron relocated to the Rohan airfield, where it handed over its R-10s to the Kharkiv Aviation School and began retraining on Su-2 aircraft. According to the memoirs of veteran of the 317th Reconnaissance Aviation Regiment, hero of the Soviet Union, Volodymyr Fedorovich Anisov, in the first months of the war, this regiment, in addition to SB aircraft, also used R-10, R-5, and Yak-2 reconnaissance planes. Of particular interest is the combat path of the 7th Army Aviation Squadron, which fought most actively on the R-10. The squadron began the war at the airfield of the city of Pavlohrad, with 21 R-10 reconnaissance planes and 2 I-15 BIS fighters. Later it was redeployed near Chernihiv, where in mid-July it was incorporated into the 62nd Bomber Aviation Division, part of the air forces of the 5th Army of the Southwestern Front. The squadron's first reconnaissance flights were carried out along the routes Mozyr, Turiv, Novohrad-Volinsky, Zhytomyr, Slavuta, Shepetivka, Zhytomyr, Novohrad-Volinsky, Korosten, and Ovruch, Korosten, Malin, Radomyshl, Korostyshiv, Irpin. Special attention was given to the first route, where the 21st Army was operating, about which the command of the 5th Army had no information. The mission was successfully completed, restoring contact with the defending troops. One of the most effective crews in the 7th Army Aviation Squadron was that of Lieutenant Konstantin Borisovich Radenko and Navigator Lieutenant Mikhailo Mikhailovich Lobachov, who by September had flown about 50 combat sorties. Here are some episodes of their combat work. On one occasion, they were ordered to photograph a column of tanks from Guderian's group that had broken through. After flying over the column and successfully photographing it, the pilots attempted to bomb the advancing tanks. However, their R-10 was damaged by anti-aircraft fire, preventing the bomb release. Barely making it back to their airfield, they were forced to make an emergency landing in a field. In another sortie, the pilots discovered a concentration of equipment near a crossing over the Teteriv River. They managed to set a vehicle on fire with machine gun fire. Despite desperate resistance, the troops of the Southwestern Front failed to stop Guderian's tanks. On July 20, 1941, the squadron received orders to relocate to the Ovruch airfield. At the end of July, 2 R-10 crews conducted reconnaissance in the area of Zarudlia, Malin, Teteriv Station. Anti-aircraft fire hit the aircraft of pilot Mykola Mikolayovich Hinut and navigator Serhiy Ivanovich Demidov. The crew perished, ramming into a group of German soldiers near the village of Sadki. In early August, aircraft of the 7th Army Aviation Squadron discovered railway platforms carrying heavy artillery on the Zhytomyr, Korosten line. An R-10 flown by Captain Anatoly Andreyovich Troshkin and navigator Boris Havrikov was dispatched to destroy them. The target was located at the Turchinka station. First, they dropped bombs, then directed Soviet artillery fire onto the platforms with the guns. However, soon a group of 4 Mi-109s appeared in the sky. In the ensuing air battle, the R-10 was set ablaze. Troshkin was killed, while Havrikov escaped by parachute. By around August 10th, only 3 R-10s and 5 MiG-3 fighters remained in the 7th Army Aviation Squadron. By September 15th, all aircraft had been lost, and only 4 pilots and 3 navigators survived. However, according to other reports, on September 16th, the last surviving R-10 of the 7th Army Aviation Squadron flew east from the Pryluki airfield. The fate of the R-10 aircraft was different in naval aviation. These machines began entering naval service in late 1938, first with the Black Sea and Baltic fleets. They were used for their intended role as reconnaissance and short-range bombers. Naval pilots were retrained on the new aircraft at the Yeysk Naval Aviation School, named after Sigismund Oleksandrovich Levanevsky. Over time, the R-10 became the main training aircraft at this school. When the war began, the school was relocated first to Mozdok, and later to the village of Borovsky near Kuibyshev. There, the R-10s were dispersed across 11 field airfields. They continued flying at the school until 1944, and on them several thousand naval aviation pilots were trained. From the first days of the war, the crews of naval R-10s, particularly the pilots and navigators of the Aviation Regiment of the Black Sea Fleet, mainly took part in attacks on enemy ground forces and equipment. In the summer of 1942, the R-10 aircraft of the Black Sea Fleet Aviation carried out missions supporting the troops defending the Caucasus. They actively assisted Army units and naval infantry near Novorossiysk and Tuapse. In August 1942, an assault aviation regiment consisting of 3 squadrons equipped with R-10 aircraft was transferred from the Kemli airfield to the Caucasus. Soon, 2 squadrons of this regiment were sent to the Baltic. Here are several episodes of R-10 combat use. On the night of June 20, 1943, a group of R-10s attacked a detachment of German combat boats, forcing them to retreat under the cover of a smokescreen. At dawn, 7 Il-2 attack aircraft arrived to assist the R-10s, escorted by 2 fighters, and sank 3 boats. German sailors called in their air support. In the ensuing air battle, 1 R-10 and 1 Il-2 were shot down. The enemy lost 1 Messerschmitt 109. On July 14th, 2 R-10s and 5 Il-2s flew to intercept a large enemy convoy of 12 ships. As a result of their strike, several ships and boats were damaged. On August 1st, 2 R-10s and 4 Il-2s struck German boats and barges near the Zalazin Bank, sinking one of them. On the same day, near Cape Achuev, a group of R-10s attacked 6 boats and 10 barges. 1 barge was sunk, and a boat was damaged. Later, the regiment's aircraft, together with coastal artillery, destroyed a boat and 2 fishing vessels and damaged a barge. From August 27th, over 3 days, R-10 aircraft attacked a German convoy near the Krivaya and Beglitskaya Spits, forcing the enemy to turn back. On August 30th, 1943, during the day, the regiment's aircraft carried out 32 combat sorties in the Taganrog area, sinking 4 barges and 2 patrol boats and damaging 8 barges and 1 steamer. In the Baltic Fleet Aviation, R-10s were in service with 2 squadrons of a bomber aviation regiment that operated on the Leningrad front. 1 squadron of the regiment, transferred from the Black Sea Fleet, arrived in Leningrad on December 31, 1942, and was stationed at Gromovka Airfield. Another squadron, which had also previously been part of the Black Sea Fleet Regiment, joined the Baltic Regiment on January 7, 1943, flying from Kamenka Airfield near Leningrad. In the Baltic Regiment, the R-10 aircraft were mainly used as night bombers, and due to their unattractive appearance and worn condition, they earned the apt nickname Extended Service Aircraft. During preparations for breaking the siege of Leningrad, R-10 crews under Leonid Kazakovich, Georgy Agafonov, Konstantin Larionov, Yuri Botvinnik, Archil Kaladze, and Georgy Gordeev carried out strikes on the runways of enemy airfields at Gachina and Siversky. The sorties were performed throughout the night by individual crews at 10-minute intervals according to a strict schedule. These strikes kept German aviation under constant tension. During one such mission in January 1943, the crew of an R-10, consisting of pilot Senior Lieutenant Grigory Ivanovich Satsuk and navigator Captain Stepan Ivanovich Ulasevich, performed a heroic act. While attacking the Siversky airfield, the enemy unleashed heavy anti-aircraft fire on the aircraft. Despite this, the crew made 2 passes and dropped several bombs. On the 3rd approach, an anti-aircraft shell struck the aircraft. The machine suffered severe damage and the pilot was badly wounded. They could have returned home, but the pilot, mustering all his willpower under continuous fire, made a fourth approach to the target, and the navigator released the last bombs. The return journey was difficult. The pilot's right arm was shattered and hung lifelessly. His strength was failing. Yet he managed to reach his airfield and land the aircraft. When the ground crew opened the cockpit, the pilot was already dead. On January 16, 1943, Pilot Sergeant Timofey Alexandrovich Zhukov and Navigator Junior Lieutenant Boris Ivanovich Gorodilov set out on a training bombing mission. After completing the task, the aircraft's compass failed. The R-10 entered thick fog and the pilot lost orientation. When the fuel ran out, Zhukov made a forced landing in eastern Karelia near the town of Palayarvi, where on the morning of January 17th they were captured by Finnish soldiers. The last known mentions of R-10 combat use are found in the service records of Finnish Air Force aces. According to these, Senior Sergeant Emil Onerva Vesa shot down an R-10 on June 23rd, and Senior Sergeant Leo Agokas claimed a victory over an R-10 on June 30th, 1944. The aircraft's purpose was reconnaissance and light bombing. The plane was a single-engine cantilever low-wing monoplane built according to the classical aerodynamic layout. The structure was entirely wooden, with all surfaces covered in fabric on aero varnish. The crew consisted of 2 people, a pilot and a navigator. The fuselage was made using monocoque technology, which meant that the strength was provided entirely by the outer skin. It was glued from 5 or more layers of thin, wooden veneer about 0.02 inches thick. The central section of the wing was made as one unit with the fuselage. The first main bulkhead of the fuselage was metal, and the engine frame was attached to it. This bulkhead also served as a fireproof barrier. On the engine side, it housed the oil tank and a fire extinguisher. Behind this bulkhead was the pilot's cockpit, covered by a transparent canopy. The canopy consisted of a fixed windscreen and a sliding cover. On the right side of the cockpit was the bomb bay release handle and the emergency bomb release mechanism, while on the left were the engine control levers and the handles for reloading the wing-mounted machine guns. To the left of the pilot's seat were the trim wheel for the elevator and the fuel tank fire extinguisher, and on the right, the manual fuel pump. Under the cockpit floor was equipment, including a battery, an oxygen cylinder, and the wheel wells of the landing gear. Behind the pilot's cockpit, the fuselage contained fuel tanks, the main tank, and an upper tank, and behind them, the bomb load. The bombs were arranged horizontally in 2 bomb bays, left and right. Each bay was closed on the bottom by a longitudinal flap. Further back was the cockpit of the second crew member, the navigator, who also served as observer, bombardier, radio operator, and gunner. The cockpit was closed on top by the transparent dome of a gun turret. For access to this cockpit, the turret dome had a hatch that folded upward. The navigator's station was equipped with a radio set and a camera. In front of this cockpit were the electrical equipment and an oxygen cylinder. The lower surface of the fuselage in front of the navigator's cockpit was glazed. The wing had 2 main load-bearing elements and consisted of a rectangular center section and 2 removable trapezoidal outer panels. The leading edge of the outer panels was swept, the trailing edge was straight. The wing skin was plywood about 0.0608 inches thick. Along the entire trailing edge of the wing, there were 2 section flaps and ailerons. The flaps were made of duralumin and their deflection angle was 45 degrees. The ailerons had a metal frame and fabric covering, were weight balanced and fitted with balance plates. The aileron deflected 30 degrees up and 15 degrees down. In the root area of the wing panel between the load-bearing elements, there was a fuel tank, and behind it, a machine gun mounting. The tail unit was cantilever. The fin and stabilizer were covered with plywood. The control surface skins were fabric. The framework was duralumin. The rudder deflected up to 25 degrees to both sides. The elevator deflected up to 22 degrees up and 18 degrees down. The rudder and the right half of the elevator were equipped with auxiliary control surfaces. The left half of the elevator had a balance plate. The landing gear was a 3-point arrangement with a tail wheel. The main legs retracted into the center section of the wing in flight, rotating toward the aircraft axis. Each main leg was a shock-absorbing strut with a brace, on which a brake wheel about 31.5 x 7.9 inches in size was mounted. A fairing that completely covered the leg in the retracted position was attached externally to the strut and brace. Retraction and extension of the landing gear were performed manually by the pilot using a crank located to the right of the seat. To compensate for the weight of the main legs during retraction, a pneumatic cylinder was used, supplied from an onboard compressed air cylinder charged to about 284 pounds per square inch. This cylinder was located behind the pilot's seat, and before retracting the gear, the pilot opened the cylinder's regulator and supplied pressure to the pneumatic cylinder. The power plant included an air-cooled piston engine with a 2-blade propeller. The engine was a 9-cylinder single-row radial. Its takeoff power was 730 horsepower at 2,200 revolutions per minute. Specific fuel consumption was about 0.66 pounds per horsepower per hour. The engine diameter was about 4.5 feet, length about 3.6 feet, dry weight about 998 pounds. The propeller was variable pitch with metal blades. The engine was enclosed by a cowling which had a carburetor air intake on top and an oil radiator air intake on the bottom. Fuel was carried in 4 tanks, 2 wing tanks and 2 fuselage tanks. The tanks were welded and not protected against bullets. The aircraft control system was mechanical. Aileron and elevator control linkages were rigid, using rods and levers. The rudder was cable operated. The aileron control rods ran in the nose portion of the wing and then along the rib. The aircraft armament consisted of 3 0.3-inch machine guns, 2 fixed guns mounted in the wing panels with 450 rounds of ammunition, and 1 in a defensive turret with 600 rounds. Fire from the wing guns was controlled by the pilot using an optical sight. Normal bomb load was about 661 pounds, 6 bombs of 110 pounds each. In the overload configuration, up to about 882 pounds. The bombs were mounted inside the fuselage on 2 cassette bomb racks. Release was effected by an electric bomb release. For aimed bombing, a bomb sight was installed in the navigator's cockpit.